Hello and welcome back. For this video, we're going to show how to solve systems using substitution. And you're going to find that substitution is a more accurate and sometimes even a quicker way of solving systems over top of graphing. So off to the side here, we have one goal: solve systems of equations by using the substitution method. And the only vocabulary we have is substitution. So if you look at our vocabulary here, substitution, that is simply replacing a variable or other unknown with an equivalent value or an equivalent expression. And I have two examples here. So I have some expression 2n plus 5, and then I tell you that n equals 4. So we can substitute n, notice how I put parentheses here, with a 4 plus 5, and then we can continue to do some sort of calculation. Down here, we have two variables, two variables and two equations. But over here on the right-hand side, we can see that we have y is already equal to 4x minus 12. So what that means is we're going to take this entire expression and substitute it in place of y over here, since in a system these two values of y should be the same. So that would look like this: 2x plus 3. And of course, when we go to substitute y, you better put parentheses first, because we're putting this entire expression right there. So we're going to put 4x minus 12 equals 10. And up here we had two variables in the problem, but down here we only have one. So we just continue solving now for x. We just want to keep in mind that once we solve for x, we still have to substitute back in to get the value of y, because the system has two solutions. All right, so here we're going to solve a system by substitution, and you'll see right here I have two basic steps. Number one, isolate one of the variables in one of the equations. And a little hint here: isolate the variable that requires the least amount of work. Step two then would be to substitute the value of that isolated variable into the other equation and solve for the remaining variable. However, in the two equations that we have, this one here and this one here, one of the variables, y, has already been isolated. So what that means is, in place of this y over here, I'm going to put the expression 4x plus 11. So 3x minus, don't forget to put your parentheses, and in place of that, I'm going to put what y is equal to, which is 4x plus 11. And it's going to equal the negative 7 that was still over there, so negative 7. And now we just solve for x. So the first thing we're going to do is distribute that negative, so that would give me a negative 4x and a negative 11 equal to negative 7. Then I'm going to combine my like terms here, so negative 3x minus 4x is going to give me a negative 1x minus 11 equals negative 7. Then I'm going to add 11 to both sides, so negative 1x equals negative 7 plus 11 is 4, but I still have to get rid of the negative there. So when I multiply both sides by negative 1, I get x equal to negative 4. So it looks like half my solution is negative 4 for x, but I got to go solve the other half for y. Now what I would do is go back to the original equations and go back to this one right here and substitute negative 4 in place of this x, and now you can solve for y. So y will equal 4 times negative 4 plus 11. So y is going to equal negative 16 plus 11. Y ends up equaling negative 5, so the solution ends up being negative 4, negative 5. We're going to try this again. Solve a system by substitution. And once more, y has already been isolated for us, so we don't have to do any work. But what I will do is take this expression and place it right here. So 3x minus 2 times, and in place of that parentheses, or in place of the x, I'm going to put, or the y, I'm going to put 2x plus 2, this is my parenthesis, still equals negative 17. So all I did was substitute the 17 here, or the y, with what y equals down here, which is 2x plus 2. So this used to be the value of y, but I replaced it with 2x plus 2. Now continue to solve, distribute, 3x minus 4x. And when I distribute the negative 2 over here, I get a negative 4 equals negative 17. Combine my like terms here, and I end up with a negative 1x minus 4 equals negative 17. Now I want to add 4 to both sides, so negative 1x equals negative 13. Multiply both sides by negative 1, and x equals positive 13. So half the answer is 13 for x. So I'm going to write that here, 13, comma. And I'm waiting for the rest of my solution. In order to solve the rest of this, I want to take this 13 and substitute it into this one. Now I could substitute it up here, but the bottom one here requires less work, so I'm going to do that one because I'm solving for y. So y is going to equal 2 times 13 plus 2. This was an x, but I replace it with 13. So y is going to equal 26 plus 2. Y finally equals 28. So the other half of the solution over here is 28. And this is the solution to the system. Okay, so you notice the title here says to solve and then substitute. So we're still going to follow these two rules, but if you look at these two equations, neither one of them has a variable that's isolated. However, notice that this x has a coefficient of 1, so I can isolate that x easily by simply subtracting 4y from both sides, so I end up with an 18 minus 4y. Now I can take this expression and substitute it back in place of this x right there and continue solving. So I'm going to go ahead and do that out to the side. So I got 5, and in place of x, I'm going to put 18 minus 4y in parentheses minus 3y equals negative 25, and then continue to solve. So first thing I'm going to do is distribute, and I got 5 times 18, that's going to give me 90. 5 times negative 4y is going to give me negative 20y. I still had a negative 3y equal to negative 25. Combine the like terms here, so I have 90. Now this is a negative 20 minus 3y, which is going to give me negative 23y, and that's going to equal negative 25. Subtract 90 from both sides, and that will leave me with negative 23y is equal to negative 115. Then I'm going to divide both sides by negative 23, and y ends up equaling a positive 5. So half of my solution gives me a 5 for y. Make sure you put that in the y position. This is where my solution is going to be. To find the x value, I'm going to go back to this equation right here and substitute the y with the 5 that I have over here. So x plus 4 times, and in place of y, we put 5 equals 18. X plus 20 equals 18. Subtract 20 from both sides. X equals negative 2. So the other half of the solution is negative 2. So these two would cross on the coordinate plane at negative 2 and 5. All right, next example says to solve or use substitution to solve when there are no or many solutions. As you can see, this one already has a y isolated, so I'm going to substitute that in. So I got 4x plus, and in place of this y, I'm going to put negative 2x plus 4. So 2 parentheses, the negative 2x minus 4, that's actually minus 4, not plus 4, equals negative 8. Continue to solve, so I got 4x plus, now right here when I multiply I get negative 4x, and then 2 times the negative 4 is negative 8, equals negative 8. Combine my like terms, well 4x plus a negative 4x is going to give me 0x. In other words, these x's drop out. What I have left over is negative 8 equals negative 8. What that means is I have either a true or false statement. So I've got a true statement, equation negative 8 equals negative 8 is an identity. Thus, there are an infinite amount of solutions. When graphed, the equations are the same line. So if I were to graph these two up here, I would only see one line. Okay, so now we're going to write and solve system of equations from a word problem, and we're going to highlight some information here. Town ordinance defines an adult tree as having a diameter greater than 10 inches, saplings having a diameter less than 10 inches. The ordinance requires that on a new building that 2 new trees are planted for each adult, 6 new trees are planted for each sapling that are felled. Last year, 167 trees were felled, and the community planted 742. The question is, how many of each type were felled? So the first thing I need to do is identify the 2 types of trees. So we have an adult tree, so let's say A equals the number of adult felled. And I'm not going to use an S for sapling, so I'm going to use C for like a child. So I'm going to put C equals number of saplings felled. So it's how many of each type we felled. Now, if you look back up, there were 167 trees in total that were felled. Well, they came from the adult and sapling. So our first equation is A plus C equals 167. So that's our first equation. The problem is I have 2 variables, which means in order to solve this, I have to come up with another equation having the same A and C in it. Well, that's where we go back into 2 new trees are planted for each, and actually each means they're multiply adult. So when they cut down one adult, they have to plant 2 new trees. So that's going to be 2 times the adults. And it says 6 new trees are planted for each sapling. Again, each means times. So we got 6 trees for each child or sapling. And it goes on to tell us that the community planted a total of 742. The total of these two means we have to add them together equals 742. So there's our 2 equations. All we got to do is solve them. And we are going to solve them by substitution. So I'm going to solve this first one for A. I'm going to isolate A. So when I isolate A, I get A is equal to 167 minus C. Since this A and this A are the same, all I got to do is substitute 167 minus C in place of A. So 2 times, and in place of this A, I'm going to put 167 minus C plus 6C equals 742, and then continue solving for the C, which was child or saplings. I can use that information to go back and solve for the number of adult trees. So go ahead and multiply there. So 167 times 2 gives me 334, and then distribute the 2 of the C, the negative C, so that would be negative 2C plus 6C equals 74. Now when I combine my like terms here, so I have 334, and negative 2 plus 6 is going to give me a positive 4C equal to, and I'm missing a number here, 742. 742. Subtract 334 from both sides, and I end up with 4C equals 408. Of course, divide that by 4, and the number of saplings, C, would equal 102 saplings. So that's the first part, 102 saplings. We wouldn't actually list this as an ordered pair. We'd actually say 102 saplings were felled. Now to figure out the number of adults, I'm going to come back up here to this C and put 102 in there. So I have A plus 102 equals 167. So I'm going to subtract 102 from both sides. So the number of adults would equal 65. So we have 65 adult trees that were felled and 102 saplings that were felled.